Hello, welcome back. We have been talking about the debugging process. So, we looked into how Visual Studio Code helped us to debug our program. We didn't talk about how to set up that, right? We didn't talk about the configurations involved, etc. That is what we are going to talk about. But even before that, Visual Studio Code is not the debugger actually. Under the hood, it makes use of a tool called as debugger. And if you are using clang compiler suite, it is known as lldb. The name of the debugger command line tool is lldb. If it is GCC compiler suite, then it is gdb. They are almost similar, but some of the instructions that you need to use along with these tools might differ, but they are almost similar. Okay. In this case, I am using clang compiler suite, so I am having lldb. Okay. So, I mentioned lldb is a command line tool, so I can always invoke that lldb like so, okay. The moment I invoke it, what happens is that it takes me into its own shell, right, and it has a lot of commands, okay. So, I am going to link to a tutorial on this lldb. If you are interested in tinkering around this low level debugger, you can do that, but that's not needed. But if you are interested, I highly recommend that you go and explore that. But now I'm just going to give you a very sneak peek of that. Okay. So when we are in this shell of lldb, we can start talking to the low level debugger. First thing that we need to tell low level debugger is what executable that it needs to actually consider for debugging purpose. So there is a command called as file, and I can give the path to the executable. Okay. The moment we do that, it sets itself, right, as a current executable for itself. So any other commands that we use to run it will actually invoke this particular executable, for example. Cool. So now what we need to do is as usual, right? So we need to plan our trip is what we said. We can do the same thing here also. We can set some breakpoints. So whatever breakpoints which are set in Visual Studio Code are not known to this session, okay, because it's a fresh debug session, so it doesn't know anything about these things. These are all maintained by Visual Studio Code in some format, okay. Let's not worry about it, but the fact is that these breakpoints have no connection with this tool. Here we need to set them explicitly. How do we do that? So there is a command called as breakpoint, and I can say set, okay. Which file, let's say we want to set it in prime.test.c, and which line we want to set, let's say I want to set it in this line, okay. Okay, the moment we do that, it can actually understand, okay, so this is a breakpoint. I need to stop whenever somebody actually invokes this debugging session. So now how do we start? So we should run the process, isn't it? So run the program. So to do that, it does support something called as process, and I can say launch. Let's give it a shot. The moment we say process launch, it knows under the hood that a.out is the executable that it needs to actually invoke, because we have set that as current executable earlier. So look at that. This is something similar to what we saw inside Visual Studio Code earlier, isn't it? It used to stop here at this line, for example. The same thing is happening, but everything is happening within the terminal, right? So let me enlarge it a little bit, and it's the same thing, and you can see some other details as to what file, what line, right, what column, right. It talks about some frame as well, so low level details, right. So now we are here. Again, we can do a step in if you want, right. So here the command is something called as thread step in, right. I can say step, I think it is step in, right. Look at that. So control goes inside is prime. Here you can see the variable values of the variables, the local context if you want. For that, there is a command called as frame variable. Okay, for example. So in this case, there is a variable called as number, isn't it? So that is shown. What is the value of that? Okay. So I'm just giving a brief peek into it. This is not at all an in-depth session or digging into lldb's capabilities. Extremely capable, very powerful tool, right? So it is outside of our scope of discussion. I'm just showing you that so that you get the taste of it and you understand what Visual Studio Code uses under the hood. Okay. All right, now you know, right? Visual Studio Code just passes across that information to this tool whenever you do those interactions in the Visual Studio Code's interface. Okay, so we did the step in. We can also do step out if you want, right? It's the same thing. Thread step out, for example, can take you out, right? I can say thread step over, for example, it can take me to the next line, right? Now again, you can step into and so forth. I can also add breakpoint at any given point of time. Breakpoint set, let's say at line number 16, let us set that breakpoint. So how do we do that? Again, we need to do this, okay? So same thing, this process we need to repeat. So line also, let's say 16, line number 16, I have set another breakpoint. I can also list all the breakpoints like this. Breakpoint list, for example, it can show you all the breakpoints that have been set. Now I can, if I want to run, so we saw that continue option, right? So you can go to the next breakpoint immediately. For that, I think you have a thread continue. Let's try that out. Yes, boom, it goes to the next breakpoint, so and so forth. Okay, so this is how the low level debugger enables you to directly interact with it, right? Fantastic. But there are some details around how it actually enables this, helping you to show where you are in the actual source code when it is actually running the binary file, the executable, right? So there are certain details around that. We will explore that. That is very interesting. So for that, what I'm going to do is I'm just continuing the execution of that. So we are coming out because it will simply resume and it will exit. No more breakpoints are there. So all good. But how all these things were happening so smoothly, right, seamlessly. All that was getting actually supported by something called as this, right? So a.out.dsim, see that, right? An esoteric extension is called as the debug symbol file. Okay, you can treat it to be kind of a mapping from the machine code to the actual source code in the high level language. Okay, just think about it. This analogy might not be exactly the same, but this helps, right? Because at the end of the day, whatever we are running inside the computer is all in binary, right? But that is of little use to us, right? Because we would like to map whenever some instruction gets executed in CPU, we would like to see the exact mapping in the high level language. That would help us to understand how the program works, right? So that is actually enabled by this file. How to generate that, right? That is an interesting question. What if we do not generate it, right? So all those details probably we will talk about in another video. Stay tuned. Thank you.